The Bible really requires every human being to have originated from one man.
Yes.
But there's a little monkey wrench that's thrown in. Most people would think Adam.
Yes.
What are we missing?
We're missing the flood.
Okay.
As far as mankind goes, men and women together, we all came from Adam and Eve.
Okay.
But there was only one man on Noah's Ark, and that was Noah.
Okay.
Now, he had 3 sons, but the sons would have had his Y chromosome.
They were originated from that man.
They originated from Noah. Noah is actually our Y chromosome ancestor. The evolutionists have this phrase, Y chromosome Adam.
Okay.
It's a little tongue-in-cheek jab at the Bible because they put Y chromosome Adam more than 100,000 years ago.
Yeah.
No, it should be Y chromosome Noah.
Whoa, okay, so this is something that we don't think about a lot. We're thinking all the way back to Adam, but we have to remember that Genesis 6 gives the account of this global flood that wiped out the human population except for the people on the ark.
Yes.
And you're saying that the men on the ark all originated from Noah. They would have had his genes, which means we are all Noah's descendants.
Yes.
Okay.
If there was any variability between Adam and Noah, it was lost
Okay.
on the Y chromosome. So if there was any Y chromosome variability, if any mutations have occurred in the family tree of Y chromosomes leading up to Noah, it's all gone. We don't know what Adam's Y chromosome was, and we never will.
There's no way to trace it back.
No. You can only go back to Noah, and you stop right there.
Yeah.
Could Noah's sons be the ancestors of the entire world population if they lived only 4,500 years ago?
Yes.
Okay.
Of human population, because God promised that he would destroy all of the people on the earth with the great flood. So my answer would be yes.
Okay. All right. So Noah, only 8 people went onto the ark, and only 8 people survived that flood.
That's my understanding from what the scriptures say.
All right, what do we find when we look at the mutational curves and all of these things?
So until recently, we did not have the ability to do until recently, we did not have the ability to trace people back because we only had one Y chromosome from the Human Genome Project back in just after the year 2000.
Okay.
But now the 1,000 Genomes Project is finished, and multiple other multi-person genomes. There's I don't know, maybe 10,000 human genomes available today.
Okay.
And that's increasing very quickly.
So now the genome is tremendous. It's a lot of information.
Yeah.
Are these complete genetic
Yes.
sequences?
Pretty much complete.
Okay.
There's little places where we can't quite sequence through, but we're talking most of the 3 billion letters in our genome
Okay.
have been sequenced for thousands of people,
Okay.
which means we have thousands of Y chromosomes. And now we can compare one person to another. And we compare people across the world.
Wow.
And we found out all sorts of things that are not supposed to be true in the evolutionary model.
So according to evolutionary biology and the accounts that secularists give, they're making assumptions about what the past was like. Now we have data.
Yes.
All right.
And the data's great. So let me show you a graph here.
Yeah.
I took all the Y chromosomes in the 1,000 Genomes Project,
Okay.
and I counted up the number of differences. There's about 60,000 places in that 65 million letter long chromosome where one man might differ from another.
Okay.
Now here's a critically important idea. The more rare a mutation is, the more recent it is.
The more rare a mutation is,
The more
recent it is. Okay.
So I probably have a Y chromosome mutation that my father didn't have. I'm one person out of 7 billion or 3.5 billion men in the world.
Right.
So that frequency of that mutation is 1 divided by 3.5 billion. It's really, really tiny percentage.
Okay.
There might be a mutation that happened in like early Africa or early China.
Yeah.
That maybe most all Chinese men today have.
Right.
That would have a high frequency in the world because a lot of Chinese men. It would have had to have happened early in human history.
So when mutations take place and a lot of time takes place, then those mutations are passed on to more generations.
Yes.
That means, that makes sense. Okay.
Yes, okay, so this chart is the number of mutations and their frequency.
Okay.
And we can see they're all piled up close to 0. In fact, I cut it off. There's actually about 53,000 mutations in that first bin.
Whoa.
But if I did that, you wouldn't have seen any of the others. So I
Right.
chopped it off at 4,000, multiply that times 10 or more,
Yeah.
And that first bin is really tall. Almost all of the variation that we find is incredibly rare. Means it's incredibly young.
Young.
Now there are some variants way out here, towards 30%, even some closer to 50%.
Yeah.
Those are ones that happened really early in human history, and they might separate like all Africans from all Europeans, or all Europeans from all the Native Americans,
Okay.
or something like that. But it's only a few.
Right.
Most of them are young. Therefore, the human Y chromosome is young. Very young.
Not 100,000.
Not 100,000 years old.
Okay.
Because we can measure mutation rates from one generation to the next. In fact, they've done a lot of genetic studies where they sequence the entire genomes of two parents and their kid.
Okay.
And a lot of them. And by doing that, you can measure how many mutations a child has that the parents don't have.
Okay.
And with the rate that we measure, we'd expect about one mutation per Y chromosome every generation.
Okay.
It doesn't take many generations to get this sort of data.
Right, which points us back to the biblical time frame.
The biblical time frame
Okay.
and the biblical Adam.
All right.
So, I'm trained in evolutionary theory. I got my degree in a completely evolutionary program, and I learned how to use some of the computer programs that will make family trees, or phylogenetic trees, they call them, evolutionary trees.
Okay.
So I did that. I took all the Y chromosomes and I made a Y chromosome family tree.
Okay.
When I did this, I was surprised because it looks like an explosion from a central point, from Noah.
Wow.
Not only that, but the length of these branches,
Yeah.
each of the branches in the tree, there's actual mutations there. You can count, which mutation led to which branch.
Okay.
Well, the length of the branches, you can get that many mutations in biblical time.
Okay, so in other words, the central point of this tree would basically be Noah,
Essentially.
and the branches, the length of the branches, are the mutations that are taking places.
Yeah.
And it's all within biblical time frame.
Yeah, we're not talking about 10,000 mutations. We're talking about a few hundred mutations in a few hundred generations.
Okay.
Boom. That's exactly the sort of time frame we'd expect. Now, you can't say this many mutations in this many years exactly.
Right.
You can say, but the ballpark, this is about what we would expect.
All right, now is there any way to track down Noah's sons? Because they would have had a slightly different genetic code, and then is that possible?
With difficulty, because we can't go back in time and sample them. We only have people alive today.
I got you.
It might be that Shem, Ham, and Japheth had exactly the same Y chromosome.
Okay.
And therefore, all the variation we see today is after the flood.
Okay.
Or, because Noah was more than 500 years old when Shem, Ham, and Japheth were born, Noah is the oldest father in the Bible. By far.
Okay.
But old fathers would pass on more mutations than young fathers.
Oh.
Because their cells have copied themselves many more times before the child is born.
More chances for
More
mutations
chances
and
for
errors.
mutations and errors to have happened. So it might be that Shem, Ham, and Japheth had very different Y chromosomes.
Uh-huh.
I don't know what the answer is because I don't have a time machine. I can't
Right.
go back and take a cheek swab and look at their DNA, but it gives us some different possibilities.
Okay.
But when we look at the tree, there's some very interesting things. First of all, there's a person near the top. His branch is much longer than his cousin's.
I see that.
But clearly, that group of people has the same ancestor. They all go back to one person.
Okay.
On the left here, there's another person who's way out compared to this cluster
Yeah.
of related people.
Okay.
Clearly, some people can pick up more mutations than others in the same amount of time. The evolutionists and a lot of evolutionary modeling depends upon something called the molecular clock hypothesis. That's the idea that mutations happen like clockwork. So in other words, if you take a branch, count up the mutations, you can count up the time.
Okay.
But we can see here that some people are way more mutated than others, more even closer related people. Clearly, you can't look at the branch length and estimate time.
Because the time all originated at one point
Yes.
at the time of the flood.
Yes.
Okay.
So The number of mutations is consistent with biblical history.
Okay.
In fact, the number of branches here is consistent with biblical history.
Explain that.
There's about 16 major families here.
Okay.
Oh, that's interesting because there's about 16 grandsons of Noah listed in the Bible. Now, it doesn't have to be true, and it could be just a total fluke, but that's really interesting. Now, if you wanted to place Noah here, the evolutionists would place him a little further to the right, Y chromosome Adam.
Okay.
I would place it maybe closer to the center. But if you have Noah, then you might be able to have Shem, Ham, and Japheth.
Okay.
This large group of people to the top right,
Yeah, I see that.
they happen to have settled in the places where the Bible says that the sons of Ham settled.
Really?
Yes. Now, people say, oh, Ham went to Africa. No. A couple of Ham's sons went to Africa. The rest of them lived in Turkey,
Okay.
Lud,
Yeah.
in Mesopotamia, Nimrod,
Okay.
in Israel, Canaan. Ham's descendants were widely dispersed, and yet when we look at these individuals, they match where Ham's descendants were. On the left, we might have Shem. There's a lot of Jewish men in the world today who belong to group J. Now,
Okay.
it's just a fluke. J doesn't mean Jewish. It just happens that a lot of Jewish men belong to group J. Well, the Jews are descended from Shem.
Okay.
They're Semitic. So that might identify Shem. The lower, that's large group of people on the bottom,
Yeah.
that might be Japheth.
So it's almost like a fan towards the bottom of the chart there, maybe Japheth.
Yes, now these are people that live in China, that's group O, India, that's R1A, I'm an R1B, I'm from Europe, the Native Americans are Q.
Okay.
This is really curious because all of these branches start with a historical individual.
Yes.
There's one person in time who gave rise to everyone who now calls himself an O. That was one ancient person in East Asia.
Yeah.
Now has maybe a billion descendants.
That is so fascinating. And that we could track it back, and that some of these things seem to indicate patterns of Noah and his family.
Yes.
All right, what's the takeaway message?
The take-home point is 1 Corinthians 15:45. Thus it is written, the first man Adam became a living being. The last Adam became a life-giving spirit. In this tree, we can see all people in the world are very closely related. Now, I'm not Jewish. How could I be related to the kinsman redeemer, Jesus Christ? Well, the answer is because we're all descended from Adam.
Okay.
He's a descendant of Adam, and so are you, and so am I, which is why salvation could come to me, whose descendants were pagans. They were, my ancestors were pagans. They were wicked. They did not know God. They did not know Jesus. And yet I'm still related to Jesus. Therefore, the blood of Christ can be on my head and salvation can come to me, even though I'm not Jewish.
The same blood.